Hello everyone again and welcome to our machine learning tips. So today we are going to be looking at a key concept in machine learning where we will see decision trees. We are starting with decision trees because most assembly techniques that we are going to see later in the lessons are mostly built using these decision trees. Things like random forest, things like the extreme gradient boosting algorithms that are used a lot in real world applications. So let's think about it. A decision tree is another type of supervised learning technique which can be used both for classification and regression problems. Um, it works like a flow chart where we have nodes. Those nodes are like decisions, which are rules on the different features that we have in our data set. And then we also have branches, which are like the outcomes of those decisions. And then we have the leaves of those trees, which are what will make what the final predictions. So the structure of a decision tree is actually what we have, like this picture on the right, where we have, I did mention that we start with the root node, where we can have our first split. Like based on this diagram on the right, we can see that H here is just like that first split. So, and then we have the internal nodes, which are the decision tests, where we have student and what the credit rating, and then we have the lead node, which are like the final outcomes where you can make a decision, like if you're a student, maybe if you are your age is equals to 32, maybe you are a student, and then there's a tendency, maybe you are making maybe a salary income of 52,000, for example, and there is a tendency that you will make a decision to buy something if we are trying to build a classification model or something like that. So how a decision tree works is you start with the entire data set, and then the next thing is split best futures based on what we are going to see later, which is what we call the highest information gain, or maybe based on some lowest impurity, and then repeat that process recursively on the subset of that data set, and then only stop when a node is pure or a stopping condition is met. So for classification problems, remember I did mention that we can use decision trees for both regression and classification problems. So for regression task, the splitting criteria is based on three different metrics. We can either use the entropy, which measures the impurity of that tree, which is like the log of P here is no is based on the number of if we are predicting a particular class. And so we can also use what we call the information gain, which is like the entropy of that parent tree minus the child nodes within those trees. Or we can also use what we call the Gini impurity to actually split these different futures in that decision tree. So one thing you have to note here is that the the one that has the lowest value, which is equals to the pure nodes, is where the future that is going to start with the splitting from. So for regression problems, remember for regression problems, I said we use the mean squared error. So any splitting criteria will be based on what? That mean squared error. So we can choose to split based on what? The future that minimizes what? That variance. So most of the times we have to put some stopping criteria we are going to see, or maybe pruning options, because one thing we have to note here is that decision trees they can easily overfit. We already know what overfitting is. For example, decision trees have that tendency of they might perform well on the training data but won't be able to generalize, because the way that splitting criteria occurs, it occurs at every level of that tree. It doesn't take into consideration the future that is picked first, um, how that future is going to behave within that entire tree. So with that condition, decision trees can easily overfit, when meaning that they can perform well on the training but won't be able to perform well on the test set. So one thing we can use here is what we call the stopping criteria, which we can limit the maximum depth of that tree. We can also limit the minimum samples that we can per split, meaning that maybe we can decide that for every split we can put it at 200 samples, or maybe we can put it at just 100 samples. Another thing we can use for the stopping criteria is to take the node purity rich. We can place a condition on that. Also, we can use what we call pruning, which we can do pre-pruning, which is like this, letting that tree stop at a particular criteria, maybe based on some information gain, or maybe based on some root mean squared error. Also, we can also put what we call post pruning, which depends on how that full tree grows, and then cut unnecessary branches. So the pros and cons of decision trees: the advantage is that they are easy to interpret and visualize. They can handle both numeric and categorical data, so there is no need to scale the data. Like in most of the methods that we have seen so far, we have been using different normalization techniques, like the standard z-score normalization, to actually scale the futures to fall within a particular scale. For decision trees, we do not need to do that. And then the disadvantage of that is that they are prone to overfitting because of the high variance, also unstable with small data changes. And then they are also less accurate than assembler method. We are going to see assembler techniques, which is like a combination of these different decision trees. We are going to see how we can, instead of basing our mind on just these decision trees, how we can combine multiple decision trees to actually lead to a particular prediction based on the kind of, whether we are using a regression problem, or maybe we are using a classification problem. So applications of decision trees, you can use it a lot in credit scoring. You can use it for medical diagnosis. You can use it for credit card fraud detection, or maybe intrusion detection. You can also use it for marketing and customer churn predictions. A summary of this lesson is that we looked at decision trees, where we can use it to split data recursively to reduce impurity. The key metrics that you can use are whether if it is a classification problem, we can use the entropy or Gini index. Meanwhile, if it is a regression problem, we can use the mean squared error. And then most of the times we require pruning to be able to let that decision tree generalize well with unseen data, that data that it wasn't used during training process. And then decision trees are the key foundations of random forest and the extreme gradient boosting algorithm. These decision trees are these random forest and the extreme gradient boosting algorithms are used a lot in most of applications, whether it is credit card scoring, whether looking at whether someone is going to default or not if you give them credit card, and so on. So guys, that was it for this lesson today. Keep following me, whether on YouTube or Facebook, for more of these tips.